The most distant object made by humans is NASA's Voyager 1 spacecraft, which has achieved entry into interstellar space. Imagine launching a spacecraft 45 years ago and still exploring areas it was never considered going, far beyond its scheduled lifespan, which is an amazing actuality of a NASA mission called Voyager, redefining space exploration. But there's something even more fascinating about this brave spacecraft. It is more than just millions of miles from where it started, but it continues to send data back to Earth using technology that is older than a cassette player. In addition, the spacecraft, commenced in 1977, just made a discovery that has slapped the scientific community in the face and captured the attention of the entire world. What could this amazing find in the extremes of space be? And what exactly does this indicate for us on Earth? It was a key moment in history when two of the most amazing space missions ever launched marked the dawn of the space age. Exploration was made possible by the brilliant mind from NASA's Gary Flandreau Laboratory for Jet Propulsion, which mapped out an ideal route for the probe to reach Jupiter and Saturn, which are far away. Using only a pencil, Flandreau discovered a startling alignment in the late 1970s and early 1980s. The four gas giants would align in a singular, cosmic configuration, resulting in a type of celestial necklace with Earth. This would allow a spacecraft passing close to each planet to gain speed thanks to its gravity as if it were being pulled by an invisible rope. Because of this, a gravitational trip that would normally require 30 years to reach Neptune from Earth would be reduced to just 12 years. But there was one catch. The alignment only took place once every 176 years. Faced with such an exceptional opportunity, NASA acted swiftly and effectively. 15 days apart, they launched two identical spacecraft, Voyager 1 and Voyager 2. In the summer of 1977, with the aim of taking advantage of this cosmic alignment, they were unaware that these twin explorers would break all records in the history of space missions. Over 45 years following Voyager 1 and Voyager 2, the spacecraft continued to operate, sending back information daily throughout the universe's history. These probes have become the farthest ships in history, having traveled significantly beyond what was first imagined. Which is impressive when you take into account that their initial mission was intended to last only for years. These pioneers of interstellar space had a lot of surprises at the beginning of their thrilling journeys. They provided incredible images of the moons from very close up of Jupiter and Saturn, revealing worlds far more dynamic and active than anticipated. These active discoveries, volcanoes, and ice fields forever changed our understanding of these distant planets, Voyager 2 in particular. On the outskirts of the solar system was the first vehicle in space to approach Uranus in 1986 and Neptune in 1989, becoming the only probe that existed between those planets, surprising researchers with findings in the previously unknown territory more than 14 billion kilometers from Earth. These Volkswagen-sized probes have defied all expectations and continue to expand the boundaries of our comprehension. The Voyager journey began with a gravity assist maneuver around Venus, a feat never before attempted by any spacecraft en route to Mercury, transforming them into genuine pioneers. During its journey to Jupiter, the spacecraft traveled 10 times the distance Mercury is from Earth and accomplished the feat of traversing the perilous asteroid belt, previously tackled by Pioneer 10 and 11 probes. But the difficulties persisted. With 69 kilobytes of memory, a fraction of what a contemporary smartphone has, the onboard computers had to rely on their own intelligence to manage the complexities of this extraordinary journey. Instrument-collected data aboard Voyager were stored on 8-track tape recorders prior to transmission to Earth through a single-use transmitter utilizing roughly the same 23 watts as a light bulb. These probes were equipped with 12-foot diameter satellite dishes to facilitate their communication via light-speed radio to send and receive messages. Despite the expanding distance from Earth, an advance of 3 or 4 light seconds each day presented major challenges. One of those challenges for Voyager 2 signals, for instance, was that they took more than 18 hours to reach Earth. And radio background noise from televisions, cell phones, and other sources made it increasingly difficult to pick up the faint signals from the spacecraft. Despite these obstacles, Voyager's investigations have defied expectations and continue to amaze astronomers with unexpected results from an interstellar void. Their journey has changed our perception of the cosmos and shifted our perspective on what lies beyond our solar system. The enigmatic Oort cloud, a vast group of comet-like objects held together by the sun's gravity and extending to the nearest star, remains a distant target. Despite the travelers continuing to move slowly toward that faraway land when they entered interstellar space, they began to traverse the divide between our solar system and the inner galaxy. The boundary was first thought to be about 50 astronomical units from Earth. As a result, it was decided to continue funding the mission despite its success. However, crossing this boundary marked a milestone. It uncovered no immediate shift in the environment, leaving scientists baffled. The passage into interstellar space was anticipated to come with a precipitous rise in the number of high-energy cosmic ray particles traveling at a speed similar to light, expelled by supernova and other cosmic phenomena. However, most of these high-energy rays can be deflected by the magnetic shield produced by the heliosphere that protects our solar system from most threats from outside. The Voyager mission team also closely monitored any shifts in the magnetic field as the spacecraft approached an interstellar medium comprised of ionized gases and influenced by the proximity of the interstellar magnetic field of stars, which was anticipated to have a different orientation compared to that of the heliosphere. But the Voyager spacecraft did not detect any significant changes in the magnetic field. On August 25, 2012, Voyager 1 finally crossed the fascinating heliopause and transmitted evidence of the anticipated increase in plasma density. Voyager 1 finally crossed the Falcons. This was surprising considering it was anticipated that when leaving a region dominated by the solar magnetic field to one affected by other stars, there would be a noticeable variation in the direction of the magnetic field. Please let me know your thoughts in the comment section if you liked the video. Make sure to click the like button and subscribe to the channel.